Welcome to the third video of Safe Human Detection in a Collaborative Work Cell training package. This video's topic is going to be connecting a device to a robot controller. In the previous video, we talked about how to position safety cameras and safety scanners in a robotic environment. In this video, we'll cover the electrical connection interfaces and how to connect a device into a robot system. For reference on electrical connections, we will use a safety scanner provided by SIG S300 standard series. We will begin by looking at the basic connections that are found on safety scanners. The OSSD or Output Signal Switching Device is an interface designed to reliably signal a safety-related event. It is designed so that when a safety violation has not occurred, the OSSD outputs are in a high state or 24 volts DC. When a safety violation occurs, they immediately switch to low state or 0 volts DC. This is to prevent unsafe operation upon cable damage or device power interruption. The OSSD is doubled on two independent channels, which are usually labeled OSSD1 and OSSD2. This is to ensure the reliability of the safety device in a scenario where the safety violation has occurred. The OSSD may be connected directly to the robot controller's designated safety inputs, or external devices may be used in case of having multiple different safety solutions or using them in a very large robotic system. The EDM or external device monitoring is an input used to monitor the states of an external safety device, such as a safety relay or logic. The EDM input should be wired as a high state signal to the external device's NC or normally closed contacts. This means that the EDM input upon a safety violation becomes energized with 24 volts DC. And if this signal is absent, an external device is not energized properly when a safety violation occurs or the external device is malfunctional. The purpose of the EDM input is to prevent resetting the safety device upon external device malfunction. And other types of electrical connections that may be found on a laser scanner include reset input, testing input, a standby input, and a warning output. The reset input is used for resetting the device in case of a safety violation and is used to bring the device back to its normal operational state. The testing input is used to test the device's functionality, which may include switching the OSSD outputs on and off. The standby input is used to set the device to standby mode when needing to work with the monitored device, for example. The warning output is used to signal a warning zone violation, which can again be used to, for example, slow down the movement of a robot. We will now take a look at the connection types found on a specific laser scanner. This is the wiring terminal that is found on the SIG S300 standard series laser scanner, and we will take a look at the connection pins one by one. The pins number 1 and 2 are the main power inputs of the safety device. This is where you connect 24 volts DC in order to power it. This voltage can commonly be found on the robot controller's external interface, or an external power source may be used. The pins number 3 and 4 are the OSSD outputs of the safety device, labeled OSSD1 and OSSD2. Like we saw in a previous slide, these can be wired directly to the robot controller's designated safety input or to an external device. At pin number 5 we have the reset input, which can be used to reset the device in case of a safety violation and bring the device back to its normal operational state. The pin number 6 is the EDM input, which can be used to monitor the state of an external safety device, such as a safety relay or a safety logic. Pins number 7 and 13 may be wired together if the device is to be used in a multiple safety laser scanner system as a secondary device or a guest device. The pin number 13 doubles as an error signal output, which can be used to signal a device error or contamination in the device's viewfinder. Pins number 11, 12, 23 and 24 can be used to wire an RS422 interface. This interface can be used for measurement data output. Pin number 14 is the warning signal output, which can be indicated that there is an object in the warning field. This output may be used to, for example, light a signal beacon or to slow down the movement of a robot. Pin number 15 is the reset required output. This output typically pulses at 1 Hz or pulses on and off 1 times per second. This signal can be used to drive a signal lamp indicating that a reset is necessary in order to ensure the operation of the device. The pin number 16 is the standby input that is used to set the device into standby mode. This means that the device stays powered on, but its main functionality will be cut. Standby input can be used when, for example, doing work on a robot or monitor device, whenever a safety scanner is not necessary to be operational. And finally, pins number 17 and 18 are used for the Enhanced Function Interface, or EFI. This interface is the safe SIG device communication which is used when working with multiple SIG devices or, for example, multiple SIG safety laser scanners. This brings us to a total of 17 connection points if you wish to use the full capabilities of this particular device. However, in our case, we can omit some of these. These are the connection points that we will use for our case. In this case, we will wire the main power input, both OSSD outputs, the reset input, the warning output, and a standby input. We will not connect the standby input to any particular device, but we will add it as a reserved wire if we wish to later on add a standby switch to our system. We will now take a look at how the previously seen connections should be connected into a robotic system. On the left you see the laser scanner and the wiring terminals that we've chosen and the labels that they represent. And on the right we have a KUKA KRC for robot controller that has been connected into a basic input-output terminal and a safety input-output terminal. As a main power source for the safety scanner, we will use a 24-volt output from the basic input-output terminal. The OSSD1 and OSSD2 outputs are connected to 2 different safety inputs on the safety input-output terminal. The reset input will be connected to a specified output on the basic output terminal, and the warning output will be connected to a specified input on the basic input terminal. And as for the standby input, we will leave it unconnected if we later on wish to add a standby switch into our robot system. In this video, we have covered the electrical interfaces of a laser scanner and how to utilize and connect them into a robot system. And in the next video, we will cover the calibration and commissioning process of this device. Thank you.